In this final video, Eric is going to go into some of the details about the programming language that's inside Vector called CAPL. This is a very advanced topic, but we're just going to get you started with it.
Okay, we're going to go back to the easy tile configuration. This is the shipping example now that's been pre-configured to connect to tile. We're going to use the shipping tile flowchart. And on the canoe side, we don't really need the display, so we'll close that. We'll go ahead and run it, just make sure everything's running okay. And we'll stop it. So what we're going to look at is back in the setup, in the simulation setup, we've already added the tile CAPL module, and we'll go ahead and click on the edit button. It'll launch the CAPL viewer. And we'll take a little bit more detailed look at what actually happens as far as the interaction of Canoe with tile. And this is a file that, although it is the template file that we ship, once your customers understand this and become comfortable with how this interaction works, it can be modified. So you can see as we scroll down, there's not a lot to it, and in fact, half of this is comments anyway. So just to kind of go through the two or three things that happen, CAPL can really set up as an event manager. When signals or environment variables change, these are what we would call callback functions. So they're very easy to program. You can set up a callback function to tie into any variable that you want. So this is how we architected this system, in that we specifically added these variables that tile knows will exist in this configuration. And in particular, when it comes to the CAPL code, it's this start test, start dwell, EUT in progress, and also the sim test time are the four variables that you'll see referenced. So first we'll look at the start test. The start test callback function is very simple. All it does in this example is it just it turns on the motor. So this motor here in the Canoe configuration would not have turned on if we hadn't explicitly put this function right here. So if we looked at the other example that we ship, the Canoe system demo, this line is commented out because there isn't a variable by this name to turn on. But as the comments imply, this is really where you can put any kind of initialization code that you want. When the tile immunity test starts, if there's something in Canoe that you need to happen, this is where you would add code to this function right here. And similarly, even though it doesn't do it in our template, you could turn the motor off when the immunity stops. Now this example, as it ships, won't do that, but you could look at the value of start test, and we'll see when we look at the other functions that is something that actually happens down here on a different variable. On this variable, we're not really looking at the value. We're just, oh, actually, I take it back. We are turning the motor off because we're putting the value of start test into the motor. So I take that back. We do turn the motor off because we're taking the current value of start test and we're setting that, we're just passing that on to the motor. So actually the motor does start, and we can see that happen when we run tile. You see the motor turn on, and then we click on finished, then you see the motor turn back off. So that actually is happening. So then we go down to the next two functions, and this is where it gets a little more complicated. So you'll see a much longer description of how this works. Is that the next flag that tile will set is called start dwell. So this is the one that is toggling high and low that we're graphing at the beginning of every frequency step. It will go high, and this is the callback function that fires when tile sets that flag. So this is where Canoe needs to get a little bit involved in this interaction, because it's up to Canoe then to set this return flag. This is how the handshaking works, to where Canoe is communicating back to tile to tell tile when the test is in progress and when it completes. So you can see what happens here is that we look at the value, similar to before. We call the get value, and here we call get value of this, which means the variable that we wrote the callback for, start dwell, and we say if it's true, then we need to start a timer, and in this case we're effectively simulating an EUT test time by actually calling another function in CAPL, which is the set timer function. So we define that as a class up here, a CAPL class or object called MS timer. And again, there's help on this, and I won't get into the details, but there's hundreds or even thousands of different functions in CAPL that can do all kinds of different things. We're just using a very simple function in CAPL, which is the MS timer, which means millisecond timer. There's another class which uses timer as a seconds variable. We're using the millisecond version. So we pull another variable out of our database, which is called the test time. So that's where we're reading this 2000, and that's how we can change that behavior as the test runs, by changing the value of that variable at runtime, because that's how we coded it to work. So we get the value, we start a timer at that time, so in this case let's say it's 2 seconds, and then there's another callback. So then we're done with that function, but then there's another callback here, which is when the timer fires. And so when this timer expires, then we just put the value 0 into EUT in progress. So this is how that interaction of the feedback works, that when tile tells us that the dwell has started, it's our responsibility to put a value of 1 to set EUT in progress high, and then after the 2 seconds expires, then we clear it, and that's what tells tile that it's okay to proceed to the next frequency step. So this interaction can be modified as the customer desires, to, instead of just using a timer, which really doesn't do anything other than just delay, this is where you could initiate an actual test and stay in this function right here until the test is complete, do whatever is desired in Canoe, and then when the test is done, then go ahead and put the value 0 back into that variable, and that will allow tile to continue. So that's a little bit of how the interaction works. There's also the ability to do debugging, and where you can actually see this happen. If you right click on the module and say debug, you get into what looks very similar to the view we were just in. Here you can set a debug, a breakpoint, and now when we run the test, you should see us go into the debugger when that variable is set. And there it is. Now we're in the debugger. Now we can step into the code and debug what we're doing on the CAPL side, on the Canoe side. So that's the interaction of the CAPL with tile.
Thank you very much, Eric. And obviously there's a lot of information to learn about this, but this is a good start for us. So thank you.